Okay, so before we begin this section, we are going to review the chain rule for derivatives just quickly. So for this problem, if I wanted to evaluate this, I would write u equals x squared plus 1. So this would be the derivative with respect to x of the square root of u, or the derivative with respect to x of u to the 1/2. And since my x and my u don't match, I'm going to have to multiply by u prime, or du over dx. So u prime here is 2x. So going as far as I can, I actually get that this is u prime over 2 square root of u. And u prime is 2x, and that's going to be over 2 square root of x squared plus 1. And the 2's actually cancel. So I just get x over the square root of x squared plus 1. And that would be my answer here. So basically, for y equals some function of u, and u is a function of x, if you want to take the derivative with respect to x of f of g of x, that's going to be the derivative of f at g of x times the derivative of the inside g prime. Now, if we were going to take the definition of an antiderivative and apply it to this, that tells us that the integral of f prime of gx times g prime of x with respect to x is going to be equal to f of g of x plus c. Now this is the undo button for a derivative. So if your derivative contains a u prime, in order to integrate, that means that your integrand right here has to contain a u prime as well. So that's what we're going to be looking at in this section, are functions that require that. So theorem 4.113, which is, or 4.13, which is an anti-differentiation on a composite function. If we let g be a function whose range is in interval I, and we let f be a function that is continuous on I as well, if g is differentiable in its domain and f is an antiderivative of little f on I, then the integral of f of g of x times g prime of x dx is equal to capital F of g of x plus c. Or, if you want to think of it this way, the integral of f of u du is equal to capital F of u plus c. Now du here is going to be g prime of x times dx, or times dx. So we've got our outside function and our inside function, and in order to integrate, we have to have the derivative of the inside function in place. Notice that there's no u prime out here. U prime only exists inside the integral before it's taken. Now whenever you do this, whenever you rewrite an integral in terms of u equals some g of x, this is what we call a change of variables. So I'm taking this and changing all my variables to u, and remember, just the variable here is a dummy variable, so we can just apply one of our formulas, and that gives us our answer. So to make a change of variables, we want to choose our u. That's usually going to be the inner part of a composite function. We want to find du, rewrite the integral in terms of u, and then go ahead and integrate that and replace our u with g of x. And you can always check your answer by taking the derivative, and when you do that, you would need to use the chain rule. So for this example, I've got the integral of x squared minus 1 cubed times 2x. So for step 1, I'm going to let u be equal to this inner function here, x squared minus 1. So for step 2, du, which is u prime dx, is going to be 2x dx. Okay, so for step 3, I'm going to come rewrite my integral. Notice that I have du here. This is u, so this is going to be the integral of u cubed du. This is easy to integrate. This will be u to the 4th over 4 plus c. And then for step 5, I just go ahead and replace it. So that's going to be equal to x squared minus 1 to the 4th over 4 plus c. So that is my answer. You don't have to check every single one, but if you wanted to, it's pretty easy. The derivative with respect to x of x squared minus 1 to the 4th over 4 plus c. Here again, if you wanted to use a chain rule, you'd let u equals x squared minus 1, so u prime would be 2x. So this would be the derivative with respect to x of 1/4 u to the 4th plus c, which is going to be 1/4 times 4 times u cubed times u prime plus 0. The 4's cancel, so I get u cubed times u prime, which is x squared minus 1 cubed times 2x. So you can see that you do get what you started with up here. So it's not necessary to check every time, but it is pretty straightforward if you wanted to do it. So if I'm looking at this one here for step 1, I would let u be equal to 3x because that's what's on the inside of my sign. So for step 2, u prime dx, or du, is going to be 3 dx. So I am going to rewrite it a little bit. I'm going to put the sign of 3x here, and then I'm going to multiply this by 3 dx because this is my du. So this will be the sine of u integrated with respect to u. And the integral of sine is negative cosine of u plus c. And then step 5, I get that that's equal to negative cosine of 3x plus c. For the next one, I would let u be the x cubed plus 2. So du would be 3x squared dx. So you can see that you do have the 3x squared. So this is the integral of u squared du, which is u cubed over 3 plus c, which is x cubed plus 2 cubed over 3 plus c. And you could have multiplied all this out on this one and then just found the integral. You would get an answer that was equivalent to this but looked a little different. There's nothing wrong with that. Now there may be a lot of cases where you're missing one of the constants that you need in order to have your g prime of x or your u prime. And if that's the case, we can use what we call the constant multiple rule. So we know that the integral of k times f of x dx is equal to k times the integral of f of x dx. Now one thing that's important to note is that this can only be done with constants, not with variables. Okay? If you think of your integral as a prison, your constants are visitors, they can go in and out, but the variables are stuck until you actually integrate. Okay? So you cannot multiply by an integral on the outside or bring an integral, or you cannot multiply by a variable on the outside or bring a variable outside the integral, only a constant. So this is an example of what this might look like. I've got the integral of x times the square root of 2x squared plus 1 dx. So I'm going to let u be the 2x squared plus 1. What's on the inside? So that means du, which is u prime dx, would be 4x dx. Now you may notice we have the x, we have the dx, we do not have the 4. So I'm going to pull a crafty little trick here. I need a 4 on the inside of that integral. I'm going to multiply by 4 over 4 on the outside. Now I can do that because 4 over 4 is just 1, so I haven't really changed the value of the integral at all. I want one of these 4's on the inside though. So what I'm going to do is I'm going to take the top 4 and I'm going to use this visitor rule here and I'm going to move it inside. But I'm going to leave the other 4 on the outside. So this gives me 1/4 times the integral of 4x times the square root of 2x squared plus 1 dx. Or if I just wanted to reorder things just a tiny bit, I've got 1/4 times the integral of the square root of 2x squared plus 1 times 4x dx, which is 1/4 times the integral of the square root of u du, now that I have my du here, or 1/4 times the integral of u to the 1/2 du. So that'll be u to the 3/2 over 3/2 plus c. And if I flip and multiply, I'm going to have 1/4 times 2/3 u to the 3/2 plus c. So that gives me 1/6 u to the 3/2 plus c. I promise we're almost done. That'll be 1/6 times 2x squared plus 1 to the 3/2 all plus c. And that would be an appropriate place to leave my answer. If I'm trying to find the integral of cosine of 5x dx, if yours says a squared up here, just ignore it. We're going to just do the integral of cosine of 5x. I would let u be equal to 5x, so du would be 5 dx. So I'm going to multiply by 5 over 5. And I'm going to bring one of these 5's in. I'm just going to go ahead and stick it back here. So this would be 1/5 times the integral of cosine of 5x times 5 dx, which is 1/5 times the integral of cosine of u du. The integral of cosine is sine of u. And all that's left to do is plug in my u. So I get 1/5 sine of 5x plus c. And we can generalize some of the more common u substitutions into general integration rules. And in fact, most of the time when you see integration rules from here on out, they are going to be expressed in terms of u instead of x, just because it allows you to generalize them a little bit better. So if g is a differentiable function of x, then the integral of g of x to the n times g prime of x dx is g of x to the n plus 1 over n plus 1 plus c, as long as n is not -1. Or if you want to look at it as the integral of u to the n du, that's u to the n plus 1 over n plus 1 plus c. So we've done some of these already. This is just kind of formalizing it, but if I let u be equal to 4x minus 2, then du would be u prime dx, which would be 4 dx. I've already got the 4, I just kind of need to bring it in a little bit. So this would be 4x minus 2 cubed times 4 dx, which is u cubed times du, which is u to the 4th over 4 plus c, or 4x minus 2 to the 4th over 4 plus c. So nothing has changed, it's just a statement of this in the general sense. Now this example is interesting because you could absolutely multiply this out. There's nothing wrong with that. And that might be your first instinct, and that's completely okay. There's nothing wrong with just multiplying that out and finding the integral. However, if you notice that if you let u be equal to x squared plus x, du, which is u prime dx, would have to be 2x plus 1 dx. And notice you've got that here. So if I just rewrite the order here, you might see that this is actually the integral of u du, and that's understood to be the first power. So that'll be u squared over 2 plus c, which is x squared plus x squared over 2 plus c. So again, there's nothing wrong with just foiling this out and finding the integral straight up, but you could use the special forms here as well. Sometimes you may have extra constants that are kind of tacked on here, and you can always bring those out. So like this negative right here, I don't necessarily need, because if I let u be 1 plus x squared, du is just going to be 2x dx. So I'm going to write that as a negative on the outside. I'm going to go ahead and bring that 1 plus x squared up and make that to the negative 4th power, and then I'll have 2x dx. So this is negative u to the negative 4th du, or negative u to the negative 3 over negative 3 plus c. The negatives go away and I get 1 over 3 u cubed plus c, or 1 over 3 times 1 plus x squared cubed all plus c. And that would be my answer there. This one is kind of a tricky power rule in hiding. If I let u be equal to sine of x, du would be cosine of x dx. So this would be the integral of u squared du, which is u cubed over 3 plus c. So this is going to end up being sine cubed of x over 3 plus c. Compare that to this one, where the innermost function here is going to be the x squared. So du would be 2x dx. I almost have it, but not quite. I'm going to have to multiply by 2 over 2. And I'm going to go ahead and bring the x over here. And I'll bring this 2 in. So this is 1/2 times the integral of sine of x squared times 2x dx, which is 1/2 times the integral of sine of u du, which is going to be 1/2 times negative cosine of u plus c, or negative 1/2 cosine of x squared plus c. So just like with the derivative, you may end up with situations where you have a cosine or a sine actually as your u, or the u may be whatever's plugged into the cosine or sine. Now, one thing I do want to caution you about, I said this earlier, but just to make sure we're clear, if you have something like the sine of x squared dx, just like this, u would have to be x squared, and du would have to be 2x dx. But notice that I don't have the x I need, okay? There's no x here. So what most students are inclined to do is they would try to multiply by 2x over 2x and then just bring the 2x in. But this is a big red no, okay? We do not want to do this. Remember I said earlier, you cannot move x's in and out of the integral. Whatever this variable is that you're integrating with respect to, that is a lock on that door. You cannot move it in or out. It has to already be there in order for it to be there. You can't bring it in. So we actually can't integrate sine of x squared dx. That's not something that we know how to do yet, and you're actually not going to learn how to do that until Calculus 2. So if you see something like that, if you don't have the variables that you need in order to have your u prime, you probably can't do it yet.